Hi everyone, I'm Isaac. I'm Brian. I'm Hua Han.
And I'm Asrita, all from 1SA5. We are presenting on universal gravitational constant.
We all know that the law of universal gravitation was proposed by Isaac Newton. However, what is the G constant in the equation and how was it derived? Newton established the relationship that gravitational force is linearly proportional to the product of the two masses and inversely related to the square of distance r. He came to the conclusion of this relationship by observing the trajectory of planets in the universe. However, he did not find the value of gravitational constant G in this equation.
100 years later, a British scientist named Henry Cavendish, who designed an experiment that not only proved Newton's theory, but also for the first time, precisely found the value of G to be 6.67 times 10 to the power of minus 11, also known as a universal gravitation constant. Lord Henry Cavendish was a British natural philosopher, scientist, and an important experimental and theoretical chemist and physicist. He was born on 10th October 1731 in a French city named Nice and lived a life of science. Not only was he active in the Council of the Royal Society of London, he too served in the Royal Institution of Great Britain in his late years.
From 1797 to 1798, he performed the first experiment to measure the force of gravity between masses in the laboratory, and also the first to yield accurate results for the gravitational constant. He conducted this experiment as he wanted to weigh the Earth. The first part of the apparatus, called the torsion, consists of a 61 cm long light rod which was hung freely from a wire, along with two 38.3 gram lead spheres which were attached to its ends. Another two 158 kg lead balls were located about 22.9 cm away from the smaller ones, and held in place with a separate suspension system. Externally, a light is shone onto the setup. A mirror is fixed onto the rod as well, hence reflecting the light onto a wall.
As the two larger spheres were brought closer to the smaller spheres, they both get attracted to each other, causing the rod to turn. This leads to the deflection of the light ray off the mirror as the mirror turns. This angle of deflection can then be measured and hence used to calculate the torsion force, F. Following that, the respective values are subbed into the equation to get the value of G.
Cavendish's findings are definitely of utmost importance to the world. With the G constant, scientists can now determine the mass of celestial objects, and also the mass and radius of our very own planet. It is also needed to ensure that infrastructure built is stable. However, probably the most important use of the G constant is in satellites. By using the gravitation constant and equation, scientists are able to precisely determine the exact location to send their satellites to.
Hence, you can definitely say that the importance of the universal gravitation constant is out of this world.
Thank you for watching.